is the Chemical Reactions AP worksheet. We're in 1993, question number 3. And so we have these 3 reactions, and we are trying to find the amount of oxygen dissolved in water. And so in order to do that, you titrate it first with manganese sulfate and then sodium hydroxide. And these 3 reactions happen to determine how much sodium thiosulfate is produced. So question A, according to the equations above, how many moles of thiosulfate are required for analyzing 1 mole of oxygen dissolved in water? So if you look at that, if you want to know how much oxygen is dissolved in the water, you can kind of work backwards. If you have 1 mole of oxygen, and then in the next reaction, you want to know how much of this guy you need, the thiosulfate. What does the thiosulfate react with? It reacts with the iodine. And if we kind of work backwards, the iodine is produced in this reaction from the manganese dioxide that's formed in the first reaction. And this keeps messing up on me. Okay. So for every 1 mole of oxygen, we form 2 moles of the manganese dioxide. And then for every 1 mole of manganese dioxide, we form 1 mole of I2, the iodine. Then in our last reaction here, for every 1 mole of iodine that reacts, we need 2 moles of our thiosulfate ion. So how many moles? 4 moles. Okay, and that was worth 1 point for part A in 1993. And so in the next part of that question on B, the student found that you had a 50 milliliter sample of water. And so in that water, there is some dissolved oxygen, and we want to know how much. And so if we look at that oxygen in that 50 milliliters of water required 4.86 milliliters of 0.0112 molar sodium thiosulfate to react. And so if we want to know how many moles of oxygen, if we start with our number of moles, if you know molarity and you know the volume in milliliters or liters, how do you find moles? Yeah, molarity times liters. So if we want to know the number of moles of that, if we just multiply the number of milliliters, which is, we have 4.86 milliliters, which is 0.00486 liters. And so if we multiply the molarity times the number of liters, you get, what is it? Yeah. 5.44 times 10 to the what? The negative fifth moles. And moles of what? This is actually the Na2S2O3, our sodium thiosulfate. Now we want to go from moles of thiosulfate to moles of oxygen. How do we do that? We start with our moles of thiosulfate. Use the mole-to-mole ratio. Didn't you just kind of figure that out and simplify those three reactions into one little ratio a second ago? So I know that for every 4 moles of my thiosulfate, I have reacted 1 mole of oxygen. And so if you multiply those two, what do you get? Or yes, well, divide. 5.44 times 10 to the minus fifth divided by 4. It's 10 to the negative fifth moles of O2. And do you see how the first step kind of leads you in the next step? Right up here, if I want to react 1 mole of oxygen, I just figured out in the step above that it requires 4 moles of my thiosulfate ion. So these two are in a 1:4 ratio, which is where I get this conversion factor right here. Yeah, Na2S2O3. So in problem A, I found that 1 mole of oxygen reacts with 4 moles of Na2. Well, why is it just this? Because the sodium ion is a spectator. So you can write it like this, or you can write it all together. It's the same one. Okay. So here's another question. It's kind of one of those error analysis questions. So if you were in the lab and you lost some of the I2, like it either spilled out or something happened where you lost some of the I2 or the iodine in that reaction before you added the thiosulfate ion to react with it, what would happen to your results? Okay, so if you have less I2, then what? All of this that you add in reacts with the iodine that's there. What? Yeah. Then you would have less S2O3, the sodium thiosulfate ion reacting, and then you would think you have less oxygen than you actually do. You don't know. You don't have to write a paragraph. You can do bullet points. So I'm just saying that if you had less I2, then you would use, maybe I should add the word use, less thiosulfate. And if you use less thiosulfate, you would think that you had less O2 in your sample. So less O2 would be calculated than you had in the original sample. Okay.